graphing functions. So we've worked on understanding what a function is and function notation. Let's take a look at what it means to graph a function. It means that we're trying to find sets of ordered pairs that show what the function looks like on a grid, pairs of inputs and outputs. And in this case, here we got a function g of x equals x squared plus 1, and our input is going to be put in place of x, and we're going to get an output. So when we graph a function, we want to try to use values close to 0 for our inputs. It's just a good way to find out what the graph is doing near the origin. So the values we typically want to use are like -2, -1, 0, 1, and 2. So take a minute to jot those down in your t-table. That's what I call this, a t-table. Also notice that I've written these from smallest to largest. And I just labeled these inputs so you guys remember, hey, that's what we're going to put into the equation in place of x. Alright, notice I've also said that y can be called g of x. Y is output, so is g of x. Remember, this g of x in the equation could just be a y, but now that we're using function notation, we often call it f of x or g of x. So what we're going to do is we're going to try to find the outputs for these inputs. And here's how we do that. Let's leave some room to the right so that we can put our answers in the t-table. So we're going to find g of -2. And that just means that we're putting a -2 wherever x was. So pocket, put the -2 in the pocket, and square it. And then add 1. So that very same function, but x is gone now and we have -2 in its place. So let's calculate the answer to that. You can use a calculator, but try to use your head. -2 squared means -2 times itself. That will be +4. And when we add 1 to that, we get the output 5. Let's put the 5 in our table next to the input -2. For the next one, we're going to do g of -1. And again, we put the -1 in place of x, we square it, and we add 1. -1 times -1 is +1. Add 1, and I get the output 2 to go with the input -1. You put in 0. Go ahead. Write it down. G of 0. What happens on the other side of the function? And what do you get? Take a second to do that. Alright, did you write it out like this? Did you remember to add the 1? And did you get the answer 1? Alright, let's do g of 1. And that's 1 squared plus 1. 1 squared is 1. Add 1, get 2. And now g of 2. 2 squared plus 1. 2 squared is 4. Add 1, get 5. Now, kind of interesting the way this table turned out. 5, 2, 1, 2, 5. This is typically what a quadratic equation looks like, and we'll be learning more about those in a later week. Alright, next we're going to graph these coordinate pairs. So, we've got our input, we've got our output, and these are all coordinate pairs on the graph. And I've already graphed 2 of them. I graphed -2, 5. How did I do it? I went left 1, 2, for my input, for x, and up 1, 2, 3, 4, 5. These are just coordinate pairs. You can think about them as coordinate pairs that we learned to plot in our first lesson. And the next coordinate pair is -1, 2. So left 1 and up 2. Go ahead and plot that. Next we have 0, 1. That means we don't go left or right, we just go up 1. 1, 2. Right 1 and up 1, 2. And notice it's a twin point to the one on the other side of the y-axis. Interesting. And last but not least, 2, 5. Right 2 and up 1, 2, 3, 4, 5. Did you guess where it could go? Notice we have a symmetric pattern here for this function. It's kind of interesting. It's called a parabola, in case you wanted to know. And we'll draw a nice curve through that parabola. And we've done our work for graphing this particular function.